Hello, this is Mr. Cerisa again, and again we're going to do analyzing and graphing a conic section using polar coordinates. Because this is a pretty difficult section, so I want to make sure I go through all the examples. So this time let's try a new problem, and this is going to be r equals 10 over 5 plus 4 cosine theta. And this one is going to be, I think, a challenge, one, because it's just difficult doing, but also the numbers won't work out as nicely as they did when we did the last hyperbola. So let's work this through, and like I said, the first thing you look at is to see if it's in proper form, and it's not. So we have a 5 there. We need to factor out that 5. So let me do that in the denominator. So 5 is 1 plus, and then, oh man, 5 doesn't go into 4 nicely. So we're going to have 4/5. We're going to be dealing with fractions a lot in this problem. So make sure you know how to do your fractions. 5 goes into 10 2 times. And so our simplified version is going to be 2 over 1 plus 4/5 cosine theta. Okay, so let's get all the information we can get from this. And so 4/5 tells us that's what E is, which is less than 1. So we're going to work with an ellipse this time. The plus cosine tells us it's going to be to the right of the pole. Alright, and it also tells us that the major axis is going to be the polar axis. So we can start thinking about where our directrix is going to go, which actually I just said the directrix is going to be right of pole. But how far away from that is that going to be? So we look at the P. So EP in this case is going to be 4/5 P, and that equals 2. So multiply both sides by the reciprocal. That cancels, and that will be 10/4, but of course we wouldn't leave it like that, so that's 5/2, or 2.5. So I can get started with my graph, and at least get started to see if we can figure out what that looks like. And so remember, this is a polar graph, so that's a polar axis, and this is the theta equals pi over 2. Alright, and then so we said that it's to the right, and it's 5/2. So 1, 2, 3, and so it's right in between there. So here we go. That's the directrix. Still, we have a focus right here. Alright, it's nice to just automatically start off with something. And then we have to figure out what our vertices are going to be. So seeing that the major axis is the polar axis, that means we're going to find out r of 0 and r of pi, meaning we're plugging in pi, or 0 and pi for the thetas. Okay, so let's figure that out. And our equation was 2 over 1 plus 4/5 sine, or cosine, and the cosine of 0 is 1. So that's like 5/5 over plus 4/5, so that's 9/5. So 2 over 9/5, which multiplied by the reciprocal, we get 10/9. Yeah, this is going to be ugly. So we're doing a lot of approximation on this, so it's going to be slightly over 1. So 10/9 0 is going to be one of our vertices. And so let's find out what the other one is. And this time we have 2 over 1 plus 4/5 -1. So that's the same as 5/5 minus 4/5, and that will be 1/5. And so that's 10. So remember, that means this vertex is going to be 10 pi. So we're going over in the other direction. Alright, so let's make our vertices here. And 10/9 It's about there. And then let's figure out, we have to find 10 in the pi direction. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, it is what it is, right? We can't change the numbers. So we have our two vertices. We can find our center now. So this center is going to involve taking the average of our 10/9, and technically this is negative 10, 0. Okay, so use the same angle so you're talking in the same terms. It's kind of like the same units. So we're going to have our 10/9 plus negative 10 and divide that by 2. Okay, so this is like 90/9, so negative 80/9, negative 80/9, and then instead of divided by 2, we'll multiply by a half. So 2 goes into 80, 40 times, so we get negative 40/9. So that seems like a pain. Let's just make it simpler, and then we'll say negative 4 4/9. And then that's just how it makes it a little easier to graph where that's going to be. So our center is going to be negative 4 4/9. So that's not too far from negative 4 1/2. Alright, and then let's find the other focus. So look how far away that focus is from, let's not use that. How far the focus is from the center, and then we'll just go the same amount in the other direction. So this is 4 4/9 in that direction, so we'll go 4 4/9 in this direction, and that will be a total of 8 8/9, right? So another 4 4/9. Alright, so let's put another point down for that. Another focus down, and there we go. And so now we're going to have to figure out to see where B is, so we know how high to make this this ellipse. Okay, so we have our A is the distance to the vertex, and so from the center, we need to figure out how far from the center that is. So we have, this is going to be 0 there. So it's negative, let's go with 40/9, right? And then that's from the pole, and then we also have to go a little bit more, the 10/9 over. So actually I'm going to get rid of that negative because I'm talking about the distance. So 40/9 plus 10/9, we're going to have 50/9, which that is, that's going to be what A is. Okay. And then our C, we did just find that one. That was the 4 4/9, or 40/9. So this is probably easier to think of it in as an improper fraction when we're doing this, because now, let's get rid of that. Now we have to find out what B is. So B squared is going to be our A squared minus C squared. And so that means 50/9 squared plus 40/9 squared. Hold on. I know, I said plus when it should be minus. So we're subtracting these. And so basically this is a 3, 4, 5 triangle. And so we end up with 30/9 squared. Okay, which means B equals 30/9, or 3 1/3. So let me go and mark that down. So from the center, I'm going to go up 3 1/3, 1, 2, 3, 4, and down 3 1/3. and put these in there. There's a point, here's a point, and then let's just graph that around. So go through the vertices, oops, and that was awful. So let's go through these vertices and bring it back around. There we go. So that's our ellipse. I hope this helped. I realize it was really long, but it takes a long time to do these problems. All right. Thank you. See you next time.